Alright guys, in this video we're going to be looking at solving square root equations. As you can see on number 1, we have the equation y equals the square root of x. What we're trying to do here is find the value of x that makes this statement a true statement. Alright, so the first thing we want to do is make sure that we isolate the radical, or our square root. And that, as you can see, is already done. We have the square root of x. So the next thing we're going to do is we're going to square both sides, because the opposite of square rooting something is to square it. So I'm going to square this side, and I'm also going to square this side. So if I square the 5, 5 squared becomes a 25. And if I square the square root of x, I'm left with x. The square root and the square cancel each other out. Therefore, the value of x is 25. Now, it's important that when we're working with our square root equations that we actually check our answers, our solutions, make sure that it actually makes a true statement. So what I'm going to do is out to the side, I'm going to check this. What I'm going to do is replace that x with a 25, and I want to make sure that this statement is actually true. So if I were to take the square root of 25, I get a 5, and since 5 is equal to 5, we know that this solution is correct. Alright, so again, the solution is 25, and we've come over here and proved that by plugging it in. Alright, let's try that again. Looking at number 2, we got negative 9 is equal to the square root of x. So again, the first thing we want to do is make sure we isolate the radical, isolate that square root, which again, that's already done for us. So I'm going to move on to the next step, is squaring both sides. So if I square a negative 9 squared becomes a positive 81. And the square root and the square cancel each other out, leaving me with x. Therefore, my solution to this equation is 81. However, it is important to check our answers, making sure that they actually work, make sure they actually give us a true statement. So I'm going to come over here, we're going to plug in that 81 and make sure that this is actually going to work. So if I take the square root of 81, the square root of 81 is 9. And you can see here that a negative 9 is not equal to a positive 9. Therefore, this 81 we have here is not a solution. We call this an extraneous solution. Although we did our work correctly, when we go back and plug it into the equation itself, we don't get a true statement. Therefore, this particular equation has no solution. And again, that's because when we plug in that 81, it doesn't make a true statement. Alright, let's take a look at example number 3. Number 3, we have 0.5 is equal to the square root of n. First thing I want to do is make sure I isolate the radical, which has been done for me. The next thing I'm going to do is I'm going to square both sides. I'm going to square this side, and I'm also going to square this side. So if I take 0.5 and square it, it now becomes 0.25. If I square the square root of n, I'm left with n. Remember, the square root and the square cancel each other out, which means I have a solution of 0.25. But I must check my solution. I've got to plug that in. I've got to make sure that I get a true statement. So if I come over here and I plug in that 0.25 for n, we're just going to make sure that we get a true statement. So the square root of 0.25 is 0.5. And since 0.5 is equal to 0.5, we know that our solution is correct. Okay, so again, very important to check your solutions. Alright, let's try number 4. Number 4, we have the equation y equals the square root of y plus 2. Now the first step here is to go ahead and isolate that radical, meaning make sure there's nothing outside of our square roots. So what I'm going to do is I'm going to take that plus 2 that's on the outside of the square roots, and I'm going to move it to the other side. And what we're going to do is we're going to subtract that 2. So if I subtract 5 minus 2, I'm left with 3. And if I subtract 2 from 2, I have square root of y left over. I'm not quite done yet. Still got to solve for y. And what they're doing right now is they're square rooting that y. So what I'm going to do is the opposite of that, and that's to square. So I'm going to square both sides. If I square that 3, it becomes 9. If I square the square root of y, that becomes just a y. Remember, the square root and the square cancel each other out. So what I have here is a solution of 9. But we're going to go back and check our work. We're going to take that 9 and we're going to plug it in, and we're going to make sure that we actually get a true statement here. So let me start by taking the square root of 9. If I take the square root of 9, that becomes a 3. And now if I add the 3 plus 2, 3 plus 2 becomes 5. And since 5 is equal to 5, we know this solution that we have over here is correct. So 9 again is our solution, and we prove that by plugging it in over here. Alright, let's take a look at a couple more examples. Number 5, we have the equation 4 is equal to the square root of negative 6 plus t. Notice we already have the square root isolated. There's nothing on the outside. So we're going to go ahead and move on to the next step. That's to square both sides. So if I square the 4, 4 squared becomes 16. If I square the square root of negative 6 plus t, remember all that's happening is the square root and the square are going to cancel each other out, which means that you're left with negative 6 plus t. Now remember, the idea here is we're solving for t, so I'm not quite done yet. What I'm going to need to do now is move this 6, and we're going to move that 6 by adding it to both sides. So all I have on this side is the t, and if I add 16 plus 6, I end up with a 22. So my solution to this equation is 22. However, again, I got to check this, make sure that it actually works. So we're going to take that 22, we're going to plug it in for t, and we're going to make sure that we actually get a true statement here. Alright, so the first thing I'm going to do is add the negative 6 and the 22. And if I add negative 6 plus 22, I get a 16. And if I take the square root of 16, the square root of 16 is 4. And since 4 is equal to 4, we got a true statement, which means this solution of 22 is correct. And we've just verified that that 22 is correct. Alright, let's try one last example. Number 6, we got negative 6 is equal to the square root of 2b minus 18. First thing we're going to do is isolate the radical. Move that 18 to the other side. So the opposite of subtracting 18 would be to add 18. Alright, so if I add a negative 6 plus 18, I end up with a 12. And I'm still left with the square root of 2b. So at this point I've isolated the radicals. There's nothing on the outside of the square root. So now I'm going to move on to the next step. And that next step is to square both sides. We're going to square this side, and we're also going to square this side. So if I square 12, 12 squared is 144. If I square the square root of 2b, the square root and the square cancel each other out, which means you're left with 2b. Now we're not done yet. Trying to isolate b. I want that b by itself. And right now they're multiplying by 2. So what I'm going to do is the opposite of that. I'm going to divide by 2. And 144 divided by 2 is 72. Which means my solution is 72. Alright, so now what I'm going to do is go ahead and check, make sure that that 72 actually works when I plug it in. So what I'm going to do is replace the b with a 72. And we're going to see if we get a true statement here. So if I multiply 2 times 72, 2 times 72 is 144. Next thing I'm going to do is take the square root of 144, and the square root of 144 is 12. And all that's left to do now is subtract. If I subtract 12 minus 18, 12 minus 18 is negative 6. And since negative 6 is equal to negative 6, I've got a true statement, which means my answer I have is correct. So again, 72 is my solution to this equation.